Good morning everyone. I am Tanushree Derive from Civil Engineering branch. So today we will discuss about slope and deflection equation for the cantilever beam having UDL on all over the span. So here is your diagram. So you can see this portion is your fixed support and here is your UDL which is subjected to all over of the span, and the UDL value is W unit per meter. So now we have to derive the equation of slope and equation of deflection for this beam. So first of all, the cantilever beam is subjected to UDL of intensity W unit per meter. Here A is the origin. So you can see A is the origin, that means the starting point of the beam. So now we have to take a section XX at a distance of x from the free end of the cantilever. So here is your XX section and this is situated at a distance of x from the free end, that is from the A, and the distance is x. So now we have to find out as per the double integration method. So now we have to find out the moment, that is the bending moment about the XX section. So we have to calculate the equation curvature, that is mx, moment of bending, that is moment about XX section, which is equal to EI d square y by dx square is equal to, so here for this beam the moment value will be load into distance by 2. As it is a case of UDL, so to calculate the bending moment, the formula will be load into distance by 2. So here load value will be W, distance will be x, and distance by 2 will be x by 2. Hence the whole moment will be minus Wx square divided by 2, and here minus due to the hogging moment up to the section XX. So this is your equation of curvature for this beam. So now we have to integrate this equation once, hence we can get the equation of slope, and by integrating twice we can get the value of deflection. So by integrating this equation once, we have EI dy by dx is equal to minus Wx cube by 6 plus C1, where C1 is the first constant of integration. So now by integrating this equation twice, we have EIy is equal to minus Wx4 divided by 24 plus C1x plus C2, where C2 will be the second constant for the integration. So now the equation 2 is the equation of slope and equation 3 is the equation of deflection. So now we have to find out the value of constant 1 and constant 2 by putting some condition. So the condition for the finding out C1 value, we have to put the x equal to L and dy by dx equal to 0. So we have to put this much in slope equation, that is equation number 2. So we have minus WLQ by 6 plus C1 is equal to 0. Hence C1 will be WLQ by 6. So now we can put this C1 value in the slope equation, hence we can get the actual slope equation for this beam. So now by putting the C1 value in slope equation, we have EI dy by dx is equal to minus x Wxq divided by 6 plus WLQ by 6. And now we have to find out the C2 value, which is the second constant for the twice integration of the curvature of equation. So now by putting the boundary condition, that is x equal to L and y equal to 0, and by putting this value in equation 3, that is the equation of deflection, we have minus WL fourth by 24 C1x plus C2 is equal to 0. Hence, we got the value of C1 as WLQ by 6. Hence, by putting this value here, we can find out the C2 value as minus WL fourth by 8. So now we can put the C2 value in the deflection equation, that is the equation number 3. So hence the equation number 3 will be modified as EIY is equal to minus WX4 divided by 24 plus WLQ divided by 6 into x minus WL4 divided by 8. So now this equation will be the actual deflection equation for this beam. So now we have to find out the maximum slope and maximum deflection value for the cantilever beam having UDL on all over the span. So first of all, due to the UDL, the maximum deflection will be occur at the free end, and the maximum slope also occur at the free end, because at the fixed end there will be no deflection and no slope is there. So that's why we have to consider the free end of the cantilever. So at the free end of the cantilever, the x value will be 0. So hence we can put x equal to 0 in the deflection equation, by which we can find out the maximum deflection value, as well as we can put x equal to 0 in slope equation, by which we can find out the maximum slope value. So now by putting the x equal to 0 in equation 5, hence here we have to put x equal to 0, hence this term will be 0, and here also x is there. So by putting x equal to 0, this term will be 0. So now EIY is equal to minus WL fourth by 8. So now the maximum deflection for the cantilever with UDL value, the maximum deflection will be minus WL fourth by 8 EI. Similarly, for the maximum slope, we have to put x equal to 0 in actual slope equation. That means this equation. So by putting x value equal to 0, this term will be 0. Hence, EI dy by dx is equal to WLQ by 6. Hence, dy by dx max is equal to WLQ by 6 EI. Hence, we got the value of maximum slope for the cantilever beam with UDL. We got WLQ by 6 EI. So this is all about the equation of slope and deflection for the cantilever beam with UDL on all over the span. So today this much. We will discuss rest of the thing in the next class. Thank you.